Our tutorial, Paired Prices Returns Correlation. Pairs identification consists of searching for paired asset prices which moved together based on fundamental or technical factors and initially tested through the returns correlation coefficient. This topic is part of pairs trading analysis with our course. Feel free to take a look at course curriculum by clicking link at description box below. This tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please read full tutorial disclaimer at the end of the video. Correlation coefficient consists of measuring the degree to which paired asset prices returns move together taking into consideration their standard deviation. It is used for evaluating short-term relationships. As a formula, correlation coefficient between asset Y and asset X returns is equal to, and then within the numerator we have the sum from the first to the last of the difference between asset Y returns minus their arithmetic mean multiplied by the difference between asset X returns minus their arithmetic mean. That result is then divided by the square root of the sum from the first to the last of asset Y returns minus their arithmetic mean to the power of 2 multiplied by the sum from the first to the last of the differences between asset X returns minus their arithmetic mean and that result to the power of 2. Great. So let's go into RStudio so that we can study correlation coefficient with greater detail. Excellent. So here we are within RStudio. The first step within the tutorial is to load its package, which is done with this library function and the package name. For this tutorial, we'll be using QuantMod. So we select that code line and we click Run or Ctrl Enter on the keyboard. The next step is to create the data object, which is done here as a data and it's equal to read.csv, and within it we have the name of the data file, paired prices returns correlation data, as a plain text file with .csv or comma separate values stored within the working directory, comma header equals to true. So we select that code line there and click Run or Ctrl Enter on the keyboard, and we see that it created the data object as a data frame, and if we click on the spreadsheet kind of icon there, it opens the data object, and within it we have 3 columns of data: dates, EWG adjusted, and EWQ adjusted. EWG corresponds to the ETF investment vehicle, which intends to replicate the MSCI Germany index. And EWQ corresponds to the ETF investment vehicle, which intends to replicate the MSCI France index. Adjusted because this includes adjusted close prices which were adjusted for dividends and splits. Notice that data has a daily frequency from the beginning of 2007 all the way to the end of 2016, therefore 10 years of data. So going back into the code file, the next step is we're going to convert that data, which is a data frame, into an XTS. XTS stands for extensible time series. So we override the data object at the following row, and we do so with XTS function. From data we select columns 2 and 3, and we order it with order by equals as date data column 1. So we select that code line, click Run or Ctrl Enter on the keyboard, and we see again that same data object but now as an XTS. As it's already open, we go into the data object and we see the same data for the adjusted close prices, but notice that the dates became its index. So going back into the code file again, the next step is we're going to delimit training and testing ranges. Training range is commonly used for pairs identification and pairs spread co-integration evaluation, while testing range is commonly used for pairs trading strategy calculation and performance evaluation. Notice that this delimiting included here was only included as an example for educational purposes and can be modified according to your needs. So here we create those two ranges, T data for training, F data for testing range. And from that previously created data barbell, we're going to select from the training range, which is from the beginning of the time series to the end of 2014, the first 8 years of data. For the testing range, we're going to select from the beginning of 2015 to the end of 2016, therefore the last 2 years of data. So we select those two code lines, click Run or Ctrl Enter on the keyboard. For this tutorial, we'll only be working within the training range. Therefore, the next step is that we're going to visualize paired prices chart. For that, we're going to create two variables with those paired prices. And here we have the first of this, which is T for training range, GER for those German ETF prices. And from T data, we select the first column. And then we have TFRA, which is the corresponding variable with the training range data for those French adjusted close prices from their corresponding ETF. So from T data, we're going to select the second column. So we select those two code lines, click Run or Ctrl Enter on the keyboard. The next step is we're going to visualize these two within a chart. This chart is going to have two vertical axes and they're going to share the horizontal axis. Therefore, it's done as follows. First, we plot the first time series as SU, which corresponds to those German prices within the training range, with the title of the chart, which is Paired Prices Chart. And notice that here that the X label or horizontal axis label and Y label or vertical axis label is blank. Then with parameters new equals to true, we're going to add the second time series, also with plot as SU for those French prices within the training range, in this case colored in blue. And notice here that we don't want to overwrite horizontal and vertical axis, which is done here with XAXT and YAXT, both of them none. Also notice that labels for horizontal and vertical axis are blank, and the axis we're going to add as a second vertical axis is done at side equals to 4. And last, we're going to add the legend for the chart at the bottom right, colored in black blue with LTY equals to 1. That's a solid line with the corresponding legend, as we can see, which are German and French prices within the training range. And last here with CX at 0.8, that's the proportion of the legend to the rest of the chart. So we go ahead and select all these code lines. We click Run or Ctrl Enter on the keyboard, which again is equivalent. Perfect. So right here we have the chart. Let's go ahead and zoom into it. And we have the paired prices chart. Notice that we have two vertical axes. The one to the left, which is related to the first time series we included within the chart, which were those German prices within the training range. And then we have the second vertical axis, which is related to the second time series that we included within the chart, which were the French prices also within the training range. As the legend indicates, German prices are colored in black, while the French prices are colored in blue. And notice that both of these share the horizontal axis with dates from the beginning of 2007 to the end of 2014, therefore the first 8 years of data or the corresponding training range. So let's close this chart here. And now that we've finished visualizing those paired prices chart, the next step is to calculate the paired prices returns correlation coefficient. For that, first we need to calculate those prices returns, and we do so by creating two variables, R for returns, T for training range, GER for German, FRA for French, and we're going to calculate with daily return function, and here we include their corresponding adjusted close prices, the ones we created right here above from their corresponding ETFs, and then we have here T, GER for training range German prices and FRA for training range French prices. With this daily return function, we're going to calculate the daily arithmetic rate of return. So we select those two code lines together with code names with the corresponding variable names so that we identify them, and we click Run or Ctrl Enter on the keyboard. And last, we're going to calculate their corresponding paired prices returns correlation coefficient, which we do right here with COR for correlation of those corresponding price returns. First German, then the French ones. So we select that code line there, click Run or Ctrl Enter on the keyboard, and right here within the console, we see the corresponding paired prices returns correlation coefficient being printed. Excellent. So now that we finished studying paired prices returns correlation, let's go back into the slides. And as mentioned previously, This tutorial has an educational and informational purpose and doesn't constitute any type of trading or investment advice. Please pause the video now so you can read the full tutorial disclaimer. Okay, so with this we finish this tutorial. Thank you for watching.